I decided to make a second video about integration, solving integrals for trig integrals and trig substitutions. So this is going to be section 5.7 solutions, part 2. I've already posted one video where I solved problems from this section, but the homework was 1 through 18 all. I did problems 2, 8, 10, and 16 in the previous video. So I'm going to do some more problems in this video just to help us out. So I'll start with problem number 6. Problem 6 is a definite integral. It's the integral from 0 to pi over 2. And here we have sine squared, cosine squared, sine squared x, cosine squared x dx. So this is an example of a trig integral where we have even powers of sine and cosine. And we said when we have even powers of sine and cosine, and we have a trig integral, one of our cases was if one of the powers is odd, right? That was one of our cases, but this isn't that case. This is the case where one of our powers, or in this case, both of our powers are even. And so when we had that, we said we're going to make use of our half angle identities, right? That was our substitution. So our substitution here was going to be sine squared x equals, sine starts with an s, so this is 1 subtract cosine 2x over 2. And then we have cosine squared x, and that's going to be 1 plus cosine 2x over 2. That's my little memory jogger to help you remember those identities. I remember that subtraction starts with an s, sine starts with an s, and so therefore that's how we determine which one of those, 1 minus cosine 2x or 1 plus cosine 2x, goes with sine. So if we make our substitution based on what we have there, this is going to equal the integral from 0 to pi over 2. And we're going to have 1 minus cosine 2x divided by 2. That's sine squared x times 1 plus cosine 2x divided by 2. That's cosine squared x dx. And if we multiply these together, that's going to give us a 1/4 outside. That's our constant. Integral from 0 to pi over 2. 1 minus cosine 2x times 1 plus cosine 2x is the difference of 2 squares. So that's going to give us 1 minus cosine squared 2x dx. Right? Because that's a minus b times a plus b. So when we FOIL this, we get 1 times 1, which is 1. We get negative cosine 2x times 1 minus cosine 2x. We get plus cosine 2x times 1 because it's positive cosine 2x. Those cancel. Cosine 2x times cosine 2x can give us cosine squared 2x. So this is the integral that we have after our substitution. Now, we can rewrite this if we want as 2 separate integrals. This would be the integral from 0 to pi over 2 of dx, right? Dx times 1 minus the integral from 0 to pi over 2 of cosine squared 2x dx. So the first integral is just going to give us x, right? So we have 1/4. The integral of dx is going to be x. We're going to evaluate that between 0 and pi over 2. and then minus this integral we did in class. We did this integral in class. We did an example in class where we ended up with the integral of cosine squared 2x dx, and we used our substitution. We used the same substitution here, but of course, this is cosine 2x. This is our half angle identity. So if we turn this into cosine 2x, that would be 1 plus. This is going to be cosine 2 times this angle, so that's going to be 4x over 2, and that's going to be our substitution. So we're going to have minus the integral from 0 to pi over 2, and we're going to substitute in 1 plus cosine 4x all over 2 dx for our cosine squared 2x. Now, if we evaluate this at pi over 2, this is going to be pi over 2. At 0, this is going to be 0 times a fourth. That's going to be pi over 8. So we'll just write that here. Minus 1/4. That's our 1/4 here. We're going to break this up into two integrals using our common denominator. So we would have the integral from 0 to pi over 2, 1/2 dx minus, that's this negative times this positive. Don't forget your 1/4. 1/4 the integral from 0 to pi over 2. And we're going to have cosine 4x over 2. I'll go ahead and move the 2 outside. So that'll make this 8x. And we'll have cosine 4x dx. That's 2 times a fourth to get us our 8. And we split this up, right? We rewrote 1 plus cosine 4x over 2 as 1 over 2 plus cosine 4x over 2. We're just using our common denominator. Here we have, well, here's our pi over 8. This is going to be minus, we can bring the half out. That's going to be an 8. We're again going to have the integral of dx, and that's going to be x evaluated between 0 and pi over 2. Here we're going to have minus 1/8, and we're going to do a u sum, right? We'll do a u sum here. We're going to let u equal 4x. du is going to be 4 dx. So we're going to need to put a 1/4. We need a 4 here, right? So we're going to need a 1/4 out in front to balance that. So this is going to be not 1/8, but instead 1/32. And then we're going to have the integral. Now we're not going to put our bounds down because our integral is going to be our u sub. These bounds are in terms of x. We're going to be in terms of u. So we're going to have cosine of u du. Here we're going to have pi over 8, all right? Just work it out over here and save ourselves some room. We're going to have pi over 8, that's from here. This is minus, we're going to plug pi over 2 in here, and then we're going to plug in 0. When we plug in 0, we get 0. When we plug in pi over 2, we get pi over 2. So that's going to be minus pi over 2 times an 8 is pi over 16 minus, and we have 1, right? We have 1 over 32. The integral of cosine is sine, so that's minus 1 over 32 sine of u, right? The integral of cosine is sine. Sine of u is 4x, and we're going to evaluate that between 0 and pi over 2. Now, when we do our arithmetic here, right, we have pi over 8 minus pi over 16. That's going to be pi over 16 minus 1 over 32. We're going to plug pi over 2 in here, and that's going to be sine of 2 pi. That's 4 pi over 2, or 2 pi, minus sine of 0. And both of those are 0. Sine of 2 pi is 0. Right, because the graph of the sine curve, right? Just draw yourself, if you don't remember, just draw yourself the sine curve. Here's 2 pi. The sine of 2 pi is 0, and the sine of 0 is 0. So our final answer is going to be pi over 16. Okay, so that's problem number 6. I'll go ahead and pause the recording while I erase, and I'll be right back with you. All right, for the next problem, I'll work on problem number 9. Now, 9 is one of those questions where they give us the substitution. They give us the problem that's the integral from 0 to pi over 4. And we're supposed to integrate tangent squared secant to the 4th dx. And they ask us to use the substitution u equals tangent of x to evaluate the integral. Now that means du is the derivative of tangent. That's going to be secant squared x dx, which means we're going to want to save a secant squared out of our secant to the 4th. So we're going to rewrite this as the integral from 0 to pi over 4 tangent squared x secant squared x, and then we're going to pull off a secant squared x dx to save for our du step when we do our u substitution, because this is another trig integral. And so when we do trig integrals, in this case, tangent is squared and secant is squared. They're both to an even power. And in the lesson, they told us if that's the case, then we're going to want to use our identity, right? Our identity involving tangent squared and secant squared. And again, remember, some of us, me included, every now and then we get confused by these identities. Like, for example, on the video for section 5.7 part 1, I made a mistake with this identity. But if we divide this by sine squared, we divide this by, well, we don't want to divide it by sine squared. That's going to give us the identity having to do with cotangent. If we divide it by cosine squared, we divide here by cosine squared, and we divide here by cosine squared, we're going to get tangent squared x plus 1 equals secant squared x. That's going to be the identity we use over here. We're going to want to replace this secant squared, not this one, right? Because this one we're using for our u sub. We're going to replace this secant squared with tangent squared x plus 1. And that will give us an identity that, or an integrand that we can then attack. So we have integral from 0 to pi over 4. We have tangent squared from the original problem. Not theta, Kevin, tangent squared x, pardon me. Secant squared, we just determined, is tangent squared x plus 1. And then we're going to multiply that by our du, right? We're going to just save this till the end because we're going to need this for our du. Now, when we multiply this out, this is the integral from 0 to pi over 4. This is tangent to the 4th, right? X plus tangent squared x, just distributing here. And then we have secant squared x dx. And we're ready for our u substitution. If we determine that we're going to let u equal tangent of x, then as we've written over there, du, of course, is going to be secant squared x dx. So we can rewrite this integral, no bounds, because these bounds are in x. We're now integrating in u, so the bounds are not written here. This is tangent to the 4th. That's going to be u to the 4th. This is tangent squared, so that's going to be u squared. This is du. Well, that integral is an integral we can do that without any of our fancy integration techniques. The integral of u to the 4th is u to the 5th over 5. Plus the integral of u squared is u cubed over 3 plus c. And now we can resubstitute in our value for u. Now that's going to get us Remember, when we resubstitute in our value for u, we're still going to have to evaluate this. That's going to get us tangent to the fifth over 5. And we don't need that plus c, do we? Because I forgot it was a definite integral, plus tangent to the third over 3. And we're going to evaluate that between 0 and pi over 4. Okay. So now we're going to have to remind ourselves what our graph of tangent looks like. Now remember our graph of tangent. We have asymptotes at pi over 2 and negative pi over 2. And this is just one phase of the graph of tangent. At pi over 4, we have the famous tangent of pi over 4. We're going to be evaluating that here in our problem. Well, tangent of pi over 4 is 1. Now, if you don't remember that, of course, you can just draw your triangle. You need your special triangle for pi over 4. That's 1 square root of 2. And therefore, the tangent of pi over 4 is opposite over adjacent, 1 over 1. We get 1. So we come over here to evaluate this. We're going to plug in pi over 4 here. So we're going to get tangent of pi over 4 to the fifth. Remember your order of operations here. It's tangent of pi over 4 raised to the fifth power. Well, tangent of pi over 4 is 1. Raise that to the fifth power. You're going to get a 1. So that's going to be 1/5. Plus tangent of pi over 4 cubed. Well, tangent of pi over 4 is 1. Cube that, you're going to get 1. So that's going to be 1/3 minus fundamental theorem of calculus, or your evaluation theorem. You put 0 here. Tangent of 0 is 0. 0 to the fifth, also 0. 0 divided by 5, 0 again. Likewise here, you're going to get 0. So we get the famous 1/5 plus 1/3. And we know that's going to be a common denominator of 15. So that's going to be 3 plus 5. Right? Because 5 goes into 15 3 times. 3 times 1 is 3. 3 goes into 15 5 times. 5 times 1 is 5. And we get 8 over 15. So the answer to number 9 is 8 over 15. All right, again, I'm going to pause. All right, the next problem I'll work on here on the second homework explanation video is going to be problem number 12. Now in problem 12, they give us the integral of x squared minus 1 to the 1/2 divided by x to the 4th dx. All right, it's an indefinite integral. Now in problem 12 in the instructions, they give us the substitution, right? But on a quiz, on an assessment, no one's going to give us the substitution for this. They're going to expect us to look at this integral. They're going to expect us to see that we have the square root of x squared minus 1. And they're going to expect us to know that we want to use x equals a secant of theta. Now they tell us that in problem 12. They don't actually tell us a secant theta, but we're supposed to know that our value of a here is 1 because this is x squared minus a squared, right? That's the version, or I'm sorry, the format we're looking for here. And therefore our a is 1. So we're going to use x equals secant of theta. Now that means dx is equal to the derivative of secant. The derivative of secant is secant theta tangent theta d theta. That's going to be our substitution. So this is a trig sub. So we come over here, we integrate now. We have to figure out what the square root of x squared minus 1 is going to turn into if indeed x is secant of theta. So we're going to do our arithmetic here. We have the square root of x squared minus 1, and that's going to equal the square root of secant squared, replacing x with secant theta, then squaring it, secant squared theta minus 1. Secant squared theta minus 1 is tangent squared theta. And that's going to give us tan of theta for our expression, the square root of x squared minus 1. This is called the trigonometric substitution. This is our trig sub that we've chosen to use. We picked this as our substitution based on the format that we have seen in the problem. When we saw the square root of x squared minus a constant, we said to ourselves, that's a trig sub. It's one of my 3 cases. It's the case where I use secant. So now we're going to resubstitute here. That gives me a numerator of tangent of theta, right? Because that's what my square root equals. My denominator is x to the 4th. So that's going to be secant to the 4th theta. And now dx, right now, x is secant. So we raised it to the 4th power, secant to the 4th theta. Don't forget your dx. Your dx is going to give you another secant theta times tangent theta d theta. Now we're going to simplify this. Right now we have this secant cancels one of those. So with the integral, we have tangent squared theta divided by tangent times tangent. On the bottom, we have secant cubed theta, and we have our d theta. Now we're going to change these into sines and cosines and hope something good happens for us. Tangent is going to give us, well, it's tangent squared, so that's going to give us sine squared theta divided by cosine squared theta. Secant, this is secant cubed theta over 1 on the bottom, right? So that's really, we're dividing by secant cubed, but secant, remember, is 1 over cosine. Right? So if we have down here 1 over cosine cubed theta, right? That's what secant cubed is. When we divide by a fraction, that puts cosine cubed up here, and here's our d theta. So when we're all done with this, we have the integral, this cosine squared, this cosine cubed. We end up with sine squared theta, cosine theta, right? These cancel and leave us 1 cosine d theta. Well, now we have a u sub problem. Why do we have a u sub problem? Well, our du is right here. If we let u equal sine theta, then du is going to be cosine theta d theta, and they have that sitting right here ready for us. So what do we end up with? Well, if we do our u sub, this becomes the integral. Sine squared is going to be u squared. This is going to be du. And the integral of u squared du is u cubed over 3 plus c. Now, that's great, but we're not solving the problem in u. We're not even solving the problem in theta, but first we've got to get back to theta. So that gets us 1/3 sine cubed, 1/3, there's 3 on the denominator, u cubed sine cubed theta plus c. That's still not the appropriate answer because our original problem is in terms of x. So we need to replace theta with the appropriate value for x. Remember how we do that? We come back over here, we rewrite this as, we'll put the a in, it makes it easier. So we get x over 1 equals secant of theta, or we get inverse secant of x over 1 equals theta. And then we have to remember that secant is hypotenuse over adjacent, right? Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant is its reciprocal, so it's hypotenuse over adjacent. If we draw our triangle then, pick any acute angle to be theta, it doesn't matter which one you pick. I need my hypotenuse to be x. I need my adjacent side to be a. And in this case, a is 1. If we use our Pythagorean theorem to solve for this side, we're going to find out that this side is the square root of x squared minus 1. Now we need the sine of theta. Here's theta. Sine is opposite over hypotenuse. So that means our final answer to our problem is going to be 1/3 sine of theta cubed. So first we find sine of theta. Sine is going to be the square root of x squared minus 1 over the hypotenuse x. We're going to cube that plus c. There's our final answer. Okay, that was a trig substitution involving secant. All right, I'll do one more problem. Let me pause this so I can erase, and then that'll be the end of this video. All right, we'll close out this video by doing problem number 18. 18 is the integral of x cubed over the square root of x squared plus 1 dx. So we take a look at this, we see the radical, and we think to ourselves, potential trig sub. We have the square root of x squared plus a squared. That leads us to the substitution of x equals a tangent of theta. And in this case, our a is 1, so we're going to use x equals 1 tan theta as our substitution. So dx is going to be the derivative of tangent. That's going to be secant squared theta d theta. And now we're almost ready to resubstitute, but we have to solve, right, for the square root of x squared plus 1. That's going to become the square root. X is going to be tangent, so that's going to be tangent squared theta right here from this substitution plus 1. That's going to give us the square root of secant squared theta using our identity, and that gives us secant of theta. So when we rewrite this, we have x cubed. X cubed is going to be tangent cubed theta, right? X right here is tangent of theta. We cube that. The square root turns out to be secant of theta, and dx is secant squared theta d theta from our substitution right here. Now, if we clean this up, this cancels this, and we're left with the integral, and we have tangent cubed theta secant theta d theta. X was tangent, so we cubed that. Then that got us our tangent squared. Dx is the derivative of tangent, which is secant squared theta d theta. We substituted that in, and our square root, we had x, which was tangent. Tangent squared plus 1 is secant squared. The square root of secant squared is secant. So our radical turned into a secant. Secant canceled secant, secant to the first. So this is what we have. Now, what are we going to do from here? Well, it's not a straight up u substitution, because if we take the derivative of, say we let u equal tangent, right? Say we try that. We're going to say, oh, we'll just do a u sub. I'm going to let u equal tangent of theta. Well, du is secant squared theta d theta. We don't have a secant squared. We only have secant to the first power. So we could try that, but that unfortunately doesn't work. We could turn this into sines and cosines, right? See what happens there. Tangent is sine cubed theta over cosine cubed theta. Secant, of course, is 1 over cosine theta d theta. And that would get us the integral of sine cubed theta over cosine to the 4th theta d theta. And we look at that and we think to ourselves, wow, I really don't know what to do with that either. I mean, that's an integral that doesn't scream at me, hey, solve me this way or solve me that way. We haven't seen integrals that look like that. We know what to do if we have sine cubed times cosine to the 4th, but not the ratio of sine cubed cosine to the 4th. So that idea, while it seemed like maybe that would work, it doesn't look like that's going to be our approach. So maybe we need to think about problems we've worked on in the past, like problems 9 and 10 or 7 and 8, right? Here we have an odd power of tangent and an odd power of secant. And we did problems like that. In fact, if we take a look at what we're staring at right here on the whiteboard, This is problem 7 from the homework. This is in the book. If you flip over to problem 7 is tangent cubed times secant. This is problem number 7. And in problem number 7 from the text, they tell us how to do the problem. Right? In problem 7 from the text, they tell us exactly what to do. They tell us in problem 7, use the substitution u equals secant of x. That's what they said. So we didn't use that. So we're going to come back and we're going to say u equals secant of theta. That's what they told us to do. That means du equals secant theta tangent theta d theta, right? The derivative of secant is secant and tangent. So we're going to rewrite this integral, and we need a secant and a tangent. We have a secant. We have 3 tangents. So we're going to write this as tangent squared theta. We're going to take our extra tangent, put it over here. And that's going to be our du. And now we have tangent squared. But from here, we know what tangent squared is equal to, right? We can see the identity written over here. Tangent squared is equal to secant squared theta minus 1. So we're going to replace this tangent squared with secant squared theta minus 1. Here we have our tangent theta secant theta d theta, right? That's just our straight up du. We know we're going to need that down the road. And now we can write this in 2 integrals. We have the integral of secant squared theta times tangent theta secant theta d theta, right? Minus from here, 1 times that would just be the integral of tangent theta secant theta d theta. Well, that's a straight antiderivative. Now, this is going to be a u sub, right? We have our u right here. U is secant of theta. So this is going to be the integral of u squared. U is secant. This tangent theta secant theta d theta is du. Minus the integral of tangent theta secant theta d theta is just secant theta. There's our constant. The integral of u squared du is u cubed over 3, right? So that's going to give us u cubed over 3 minus this. And before we get all excited and look at our answer and think we're done, we're not finished, because this is in terms of u and our original problem is terms of x. So we have to go back and make our substitution, right? We got to make our substitution. Right here, we have x over 1 equals tangent of theta, or we have theta is inverse tangent of x over 1. And then we remember that tangent is opposite over adjacent. That gets us our rectangle, right? That gets us our rectangle. So our rectangle is going to be, we pick any angle we want for theta that's a cube. So x is going to be the opposite side. The adjacent side is going to be 1, which means the hypotenuse is going to be x squared plus 1. And now finally, we're ready to come over here and rewrite this. We have 1/3, right? 1/3. Secant cubed. Secant is hypotenuse over adjacent, right? Hypotenuse over adjacent, that's secant. So our hypotenuse is x squared plus 1. So that's going to be the square root of x squared plus 1. Hypotenuse over adjacent for secant. So our adjacent side is 1. So we're just going to cube this minus secant of theta, right? Secant of theta. Secant of theta we just decided was hypotenuse over adjacent. So that's minus the square root of x squared plus 1 plus c. All right. So there's 4 more problems from homework from section 5.7. Hopefully when we put all those, that's 8 of them that I've done. Hopefully with those 8, you can get through the other 10, and we've mastered trig integrals and trig subs.